So I recently did a video where I tested Nvidia Rapids CUDA Dataframes on an older 8GB GTX 1070, and the results were astonishing because Rapids could load, clean and export datasets up to 22 times faster than Pandas. If you want to see the full results, you should check out that video. Now, as much as I was blown away by the speed and performance gains, I found two huge limitations to CUDA Dataframes that took me by surprise. And trust me, you're going to want to hear them because it'll affect your decision in switching to CUDA Dataframes. So let's jump into it. The first limitation is you need more GPU memory than you think. What I mean by that is, if you have 8GB of GPU memory, that doesn't mean you can handle an 8GB dataset. Call me naive or a noob or both, but I just assumed you could load close to 8GB of data since I had 8GB of GPU memory. But the maximum it could handle without issues was 2GB, only a quarter of my GPU memory. And even then, it still ran out of memory if I re-executed the same line of code, which meant constantly restarting the kernel to free up memory, which is a huge annoyance to say the least. I did try falling back to dask-cudf as an alternative, but for 4GB datasets and above, dask-cudf still didn't have enough memory to export the CSV, but it did manage to lazy import and lazy process the data. So if I want to handle 4GB datasets and above, I'd need more than 8GB of GPU memory. The lesson here is, figure out how big your data is, then quadruple that number to determine how much GPU memory you'll need. The second limitation I came across was you can't execute user-defined functions on string. Yet. Now, depending on your requirements, this may or may not be an issue, but in the basic tests that I wrote, this was a huge limitation. Let me give you an example. In my dataset, I've got a number field called BSB. It stands for Bank State Branch, and it's a 6-digit code to identify a bank and a bank branch in Australia. The requirement is to prefix BSB with a 0 only if the length is 5 characters long. If it's not 5 characters long, then don't prefix it with a 0. Therefore, we have to use an if-else statement, and with Dataframes, if-else statements are written as a location, lambda, or user-defined function, or UDF for short. Now, when you zero-fill or zero-pad a number in Python, it gets stored as a string, not as a number. So no matter which of these three functions are used, location, lambda, or UDF, the moment you zero-fill that BSB, it's stored as a string. But the problem is, you can't execute user-defined functions on string. Therefore, you can't solve this requirement using CUDA Dataframes. You have to do it in Pandas, or settle for just zero-filling the entire column like I did for this test, regardless if it was 5 or 6 digits. So depending on how often you'll need to process a number to a string with a user-defined function, this might not matter too much, but it sounds like Nvidia are already working on it. Anyway, that's it for this video. Let me know in the comments if you're using Nvidia Rapids and what your thoughts are. If you like this video, give me a thumbs up and please consider subscribing. Thanks for watching, and I'll catch you in the next one. See you later.